Now let's take our next question, that is question number 16. The question you see here belongs to section of mechanics from the chapter fluids. Here, a wooden block floating in bucket of water has 4/5 of its volume submerged. When certain amount of an oil is poured into the bucket, it is found that block is just under the oil surface with half of its volume under water and other half in oil. We have to find the density of oil related to that of water, right? So let's start with the solution. Let's understand the case here. So this is the tumbler in which there was water and the block was initially like this. This is submerged portion. This is 4/5 of the volume of this block and this is water inside, right? So the buoyancy force which is up and weight is balanced, right? So you will write buoyant force which is equals to 4/5 volume which is submerged into density of water into G, and this should be equal to mg. This would be our first equation. Now in the second case, when some oil was poured over the water, then the condition changed. So let's take this and this. This was the oil portion. So block was lying something like this, where some portion, that is half of the volume, is in water and the other half, this one, that is this portion, is in oil, right? Now in that case there are two buoyant forces, one due to oil and one due to water. They are balancing the weight downwards. So you will write here BO will be equal to V/2 sigma O into G, and buoyant force of water would be V/2 sigma W into G. So mg would be sum of buoyant force due to oil plus buoyant force due to water. So let's have it. So this is equals to V/2 sigma O G plus V/2 sigma WG. And this weight, if you see here this equation from equation 1, it is 4/5 V sigma WG. So I will write here 4/5 V sigma WG. On solving here, you will get sigma O by sigma W is equals to 3/5, which is equals to 0.6. Let's see which is the best suited option. So among the four options given to us, yes, option number 4 would be the right answer. Let's move on to our next question, that is question number 17. Now, the question you see here belongs to section of heat and thermodynamics from the topic heat transfer. As per the question, there are two materials having coefficients of thermal conductivity 3K and K and thickness D and 3D respectively. They are joined to form a slab. The temperatures of the outer surfaces are θ2 and θ1, and we have to find the temperature of the junction point, right? And this is a case of equilibrium case where the amount of heat entering here will exit from this point, right? So the heat amount here and the heat amount here should be same. So let's see what the solution would be. So you will get H is equals to 3Ka θ2 minus theta divided by D. This is the heat which is going on this side, and that should also be equals to H for this portion. So I will write Ka theta minus θ1 divided by 3D, and both 1 and 2 you can see that from right hand side and left hand side are equal. So being this can be written as 3Ka θ2 minus theta upon D. This should be equal to Ka theta minus θ1 divided by 3D. On solving this, you will get theta is equals to θ1 by 10 plus 9 θ2 by 10. Let's see which is the best suited option here. So among the four options given to us, option number 2 is the right answer to this question. Now let's move on to our next question, that is question number 18. Now the question you see here belongs to section of mechanics from the chapter units and measurements. Here the area of square is 5.29 centimeters square. The area of 7 such squares taking into account would be. So in order to find the area of the 7 such squares, total area would be equal to 7 into this value, that is 5.29 centimeters square, which will come up to 37.03 centimeters square. But if you see the 3 significant figures here, so you will count up to this place only. So the answer should be 37.0 centimeters square. So answer to this question should be option 2, right? Now let's move on to our next question, that is question number 19.